All right, today we are going to do a quick overview of what we've discovered when multiplying decimals. All this work will be helpful as we work towards our project eventually, as we're looking at both models and then the algorithm or procedure that we can use. We're going to start by looking at what happens when we multiply 2 3/10 times 1 and 2/10. We're going to look at how we can do this with a model in two different ways. The first way we're going to do it is with our base 10 blocks like we did in class. So 2 3/10 is going to be modeled with 2 wholes, so 2 flats, and then 3 of the tenths, which were the lines. And then 1 2/10 we're going to model along the side the same way. So 1 whole and 2/10. And then we're going to fill in based on our multiplication. So I'm going to start, and if it helps, remember we can also split up our box into our separate pieces. So I'm going to start up here looking at the area of this box, which is going to be a dimension of 2 by 1, which gives us 2 times 1 or 2. Then I'm going to move to this box, and now I have 1 times 3/10. And the nice thing about multiplying by 1 is the value stays the same. So in this box, it's going to be 3/10. Now I've completed this whole first row. I'm going to move down here. So now I have 2/10 times 2 wholes. Now, if I didn't remember what this is, I could also just do 1 at a time. So I could do 1 times 2/10 and then 1 times 2/10 again, breaking it up even further. So when we multiply by 1, our value stays the same. Or if I have two groups of 2/10, I end up with 4/10. Our last one is the one that's probably the most challenging to remember, and this is when we're multiplying tenths by tenths. So when I have 3/10 times 2/10, or if I just do a tenth times a tenth, I just have this space here. So I can't fit a whole, I can't fit a tenth. All I can fit in there is that 100th piece. So each of these is going to be filled in with 100th. And then I can just add all of my values together. So here I have a value of 2. For the red pieces. For our green, we have a total of 7/10. And for our yellow, we have a value of 6/100. So if I add those all together, we end up with a final amount of 2 76/100. Now, if we didn't want to use the model, another way we could do this is numerically, but still using an area model. So I'm going to go ahead, split up my piece. 2 3/10 is the same as 2. And some of us, you're using the fraction equivalent, so I could also just do it as 3/10 that way. And then we have 1 2/10 this way. So then I start to fill in what I know. So I know 2 times 1 is 2. 3/10 times 1 is 3/10, but now I'm going to go ahead and write it as its decimal equivalent. 2 times 2/10 is going to be 4/10, which is 0.4. And then 3/10 times 2/10 gives us 6/10, which is, 6/100, which is 0.06. And just like I did on the visual model, I'm going to go ahead and just add all those. So I have 2 plus 3/10 plus 4/10 plus 6/100, lining up all those decimal places. I still end up with a total of 2 76/100. So that's two different ways that we can use models to multiply decimals. As we talked about in class, though, we don't always want to have to use visual models when we're multiplying. So then we started doing our exploration where we were using the calculator and looking for patterns. And we started to see the pattern of it's really just multiplying the numbers and then figuring out where the decimal point has to go. And one of the ways that we can look at that is that we can think about what are we going to do to multiply these numbers as whole numbers. So when I look at 3 42/100, what do I have to do to change this to a whole number? Well, I need to multiply it by 100. And if I multiply it by 100, it's like moving the decimal point over 2 spots. So, or you can think about it as 10 to the second power. So this becomes just 342. And I'm going to do the same thing with 8/10. So here I could multiply it by 10, or just 10 to the first, and that's going to become just 8. Now I'm just going to multiply this like I would normally. So I could do 8 times 2, which is 16. 8 times 4 is 32, plus 1 is 33. 8 times 3 is 24, plus 3 is 27. So now I have this value of 2,736. But we know that's not correct because we have to look back at the fact that we changed our values. So if you think, as we look at this, we see that we changed the first one by a value of 2 to the second, and the second one has a value of 2 to the first. So altogether, we changed it a value of 10 to the third. So we changed it by 3 decimal places, which means in my answer, I'm going to change it by 3 decimal places. So I have to go back. So right now my decimal point is here. I'm going to count back 3 spaces. So when I bring this to be my final answer, I end up with an answer of 2 and 736 thousandths. And if we think about, does this answer seem reasonable? I'm starting with an answer of about 3.5, and I'm taking 8/10 of it. So I'm taking less than 1, so my answer should get smaller. This answer is smaller than 3 and 42/100ths, but it's also more than half. So this would be a reasonable answer in this case. So why don't we go ahead and pause the video and see if you can do this next one on your own, and then we'll kind of come back and check together. So on this one, we noticed we're going to have to multiply it by 1,000, or 10 to the third, because we're going to have to move 3 decimal places to make this into 14. 6/10, we're going to have to multiply by 10 to the first to make it just 6. So I'm going to multiply 14 times 6. So 6 times 4 is 24, and then 6 times 1 plus 2 is 84. So here, if we look at 10 to the third and 10 to the first, we've changed it by a total of 4 decimal places. So that's what I have to take into account here, is that I'm going to move it 4 decimal places. My decimal points at the end, I'm going to count back 4. 1, 2, 3, 4. And we're going to fill in with zeros. So when I come back to my actual answer, we end up with an answer of 84/10,000ths. So I want you to kind of just reflect on some of the stuff that we have found, and let's just kind of summarize what we've talked about in class. So if you think about what we've looked at, is we've noticed that you can count the number of digits behind the decimal point to help us determine the placement of the decimal point in the product. So whatever we end up moving in our multiplication problem is what we end up moving back in our ending problem. So go ahead and finish these up and then put these in your binder when you're done, and you can start on your practice.